So we have here sample problem 3.9. We have here 4 tugboats are bringing an ocean liner to its pier. Each tugboat exerts a 5,000-pound force, that is, 5 kips of force in the direction shown. Determine the equivalent force couple system at the foremast O. Here, the point on the hull where a single, more powerful tugboat should push to produce the same effect as the original 4 tugboats. So, in our problem, we have an ocean liner wherein there are 4 tugboats pushing this to bring this to its pier. So, for the first tugboat here that is at an angle 60, since every tugboat here exerts a 5,000 force, and this 5,000 force is applied at 60 degrees from the horizontal here, we can resolve these 5 kips of force to its component, horizontal and vertical. So to get the horizontal component of 5 kips at 60-degree angle, here we have 5 cosine 60. And that 5 cosine 60, that is equivalent to 2.5, directed towards the positive x direction. Its component along y, we have, if this one here is cosine, the other should be sine. So we have here, we have 5 sine 60. And that is equal to negative 4.33j. Negative j means that our component here is directed towards the negative j direction or going downward. Okay? So how about for our second tugboat? So our second tugboat is applied at point here wherein the proportion of its x and y axis is about 3 and 4. So if we get the hypotenuse here of this triangle here, we have square root of 3 squared plus 4 squared, that would be square root of 9 plus 16, that is 25. So square root of 25, we have our 5 here. So if our force, that would be the same, that is 5 kips. If we try to resolve it again into its y and x component, for the x component here, if we try to resolve this force, this one here, the x component, since this x is parallel to 3, to get the component of our 5 kips or 5 kilopound force along the x direction, we simply proportionate, no? We have 3 over 5 multiplied by 5. So 3 divided by 5 times 5, we have our 3 here. To get the vertical along our y-axis or parallel to the y-axis, since this one here is parallel to 4, to get the component here, we simply just ratio the 5 over the 4 over 5, or this part here of the triangle divided by the hypotenuse, which is 5, and then multiplied it to 5 kips. So 4 divided by 5 times 5, we have here 4. So negative means it's going to the negative y-axis. So for our tugboat 3, since it's purely vertical, yan, no component along x, and since it is said that the tugboat exerts a 5,000 force, and our tugboat 3 here is along vertical and no component along horizontal, so therefore, the force or the component of the force along y here is 5, and along x is 0. So how about tugboat 4? This one here. So it's at angle 45. So to get the x component, we have cosine, and then for the vertical, we have sine. So cosine 5 cosine 45, we have that is equal to 3.54. And for 5 sine 45, we have here 3.54. So let's proceed to part A. We are asked to find the equivalent force couple system at the foremast O. So at the very beginning, we resolved all the forces here exerted by tugboats 1 to 4 into its component. So we are asked here to create an equivalent force couple system wherein we replace all the forces here by a force or equivalent force couple system that would be applied at point O. So here, if we try to redraw our ocean liner here, somehow the point where we apply our equivalent force couple is at point O here. So we have here a force, assuming that it's directed towards the direction, and a couple. Okay, yan. Assuming that our couple here is directed or rotated counterclockwise. Okay, so this is our force. So to get the force, what we do here is to simply add all the forces. So all these forces here. And how do we get the moment? So the moment at point O, we can get that by adding all the R cross F pivoted along point O.
So, ayan lang. So,
For our force, for our equivalent force couple, to get the force, we need to add all the forces. So what are those forces? We have force 1, which is 2.5I minus 4.33J. For our second force, we have 3I minus 4J. Our third force, we have negative 5J. And lastly, for our fourth force, we have 3.54I plus 3.54J. So adding some similar terms, all I and all J's, we have our R equal to 9.04I minus 9.79J. So this would be our force. How about the couple? So to get our couple at point O, we simply just add all the R cross F pivoted at point O. So what are those moments? So we have this moment pivoted at point O, this moment here, this force here, pivoted at point O, this force, and this force here. Okay. So for our F1 here is its F is equivalent to 2.5I minus 4.33J. Its R is from the pivot point going to that direction here. So our R here is simply just, we have here going to the negative x-axis now, we have negative 90, and going upwards, we have positive 50. So we have here 90, negative 90I plus 50J. Cross our F, which is our F1, we have 2.5I minus 4.33J. Yan. Plus, for our second moment, F2, our moment arm is from point O going to this point here. So to get from point O to this point here, we need to go 100 units to the right and 70 units going upward. So we have here 100I plus 70J. Okay, so we have here 100I plus 70J. That is for our R. And for our F2, we have this one here, 3I minus 4J. So let's continue for our F3. Our F3 is, its moment arm is from point O going to that direction. So to get from point O to this direction, we need to go 100 plus 200 plus 100. We have 400 units going right and 70 units going upward. So we have here 400I plus 70J cross our F, that is just negative 5J. And then lastly, for our force F, its moment arm is from point O going to that direction. So to get from O to this direction, we need to go 300 units along X, and going downward along Y axis, 70 units. So we have here 300I minus 70J. Cross our force F as 3.54I, this one, plus 3.54J. So to get the cross product of this R vector and F vector, we all know that I cross I, that is equal to 0. So if we use FOIL method here, I cross I, that is 0. So what we only need to do here, since the unit vectors involved here are only I and J, we only need to multiply the outer and the inner. So we have outer I cross J, and then here we have J cross I. So to do that, if we meticulously multiply every terms here, the answer would be, we have negative 90 times 2.5I, that would be 0. So we have here this one, negative 90I times negative 4.33J, we have here 390K. And for 50J cross 2.5I, J cross I, that would be negative 50 times 2.5, we have here negative 125K. And if we continue for the other terms, we have negative 400K minus 210K minus 2000K plus 1062K plus 248K. That would equal to, if we add all this K here, we have negative 1035K in total. So this would be our couple at point O. So now for our part A, we have our force and our couple here. Okay. Now for B. So what we have in B is we need to find the point on the hull where a single more powerful tugboat should push to produce the same effect as the original four tugboats. So, if we draw again our hull, I mean our ocean liner, if we have, say this is our ocean liner, yan. So, our point O here, we have our force, the equivalent force as 9.04 I minus 9.79 J. We have a positive I and a negative J. So that force would be located at the fourth quadrant because we have a positive X and a negative Y. So somehow our force is directed towards that direction. Okay? And since our couple is have negative K, that would mean that the rotation is clockwise, no? To the negative z-axis. So we have a clockwise rotation for our moment. Now, what we want to know on B here is we need to locate the point on the hull where a single more powerful tugboat should push to produce the same effect. Now, knowing that our force is directed towards that direction, therefore, our powerful tugboat should be placed at the top here because our tugboat should be pushing our ocean liner downwards, okay, because the force is directed towards the direction. So somehow our tugboat here is located at the upper side of our ocean liner. So somehow towards that direction. So the force it exerts is towards that direction. Okay. So if we move this force here towards this direction, we know that we need to add an additional couple. No? If this couple here, the negative 1035K couple, we know that it's a free vector. So we can just simply transfer that couple to this point and nothing would be added. No? So if we try to transfer that couple here, yan, couple. Yan. So that couple is negative 1035K. Transferring this force here from this point to this point, that would mean that we need to add additional moment R cross F pivoted at the new location. Say this point here is point C. No? So pivoted at point C here. And since what we want here is the exertion of the force of the powerful tugboat at point C here, wherein there would be no couple existing, the negative 1035K here plus R cross F pivoted at point C should equal to 0 in order that at this point only the force would exist. Okay? So ayan. So we write our equation. We have here negative 1035K plus R cross F pivoted at point C that should equal to 0. So let's try to substitute. We have here negative 1035K plus what would be our R? So the R is the distance from the new pivot point going to that direction, point O. So to get from point C to point O here, we need to go X units from or along the X axis and Y units going down along the Y axis. So since we already know the distance from this point here going downwards, that would equal to about 70 feet here. So we have here 70J, that would be negative. And the distance from point C going to this direction here, we don't know what's its distance. So we denote that as X. And since it's going to the negative X axis, we have here negative XI. So therefore, our R here, that would mean that it's equal to negative XI negative 70J. Okay? Yeah. So, write lang natin, we have negative xi minus 70j cross our f. So our f here, that would be the same f as what we have here, negative 9.04i minus 9.79j. So rewriting that number or that value, we have 9.04i minus 9.79j. Yan. That is equal to 0. So let's try to expand. We have here negative 1035K plus I cross I, we have 0. I cross j, we have positive k. Negative times negative, we have positive. So we have positive 9.79x k. And then here we have j cross I, that is negative j cross I, that would be negative k. Times negative, we have positive. So we have positive 70 times 9.04 k equal to 0. So the k is cancelled. What we're left here is, if we arrange this one here, 9.79x to the left, and this one here transposed to the right, we have here 9.79x, that is equal to positive 1035 minus 70 times 9.04. Divide both sides by 9.79, cancel. Here we have also 9.79. We have here our x equal to 41.1 feet. So therefore, the force should be located at 41.1 feet from our point O here along the x-axis.